All right, so here we're going to look at how to convert between moles and grams using dimensional analysis. So the first one here, how many moles are in 62.5 grams of water? So again, we're going to start with what we're given, the 62.5 grams of water, and we label everything. It's going to be really important later on as we get into more complex things. So you want to start building those habits. Put that over 1 just so we don't accidentally put something else there. Times, we're going to draw our line. And now we want to cancel grams of water. So grams of water goes on the bottom, and we want to get to number of moles. That's what we want to know here. So we have to know the relationship between grams and moles. So that relationship is the molar mass. We know that calculating the molar mass of water with 2 hydrogens and 1 oxygen is 18.02 grams per mole. So we're going to have 18.02 grams on the bottom to cancel out the grams of water here, and then 1 mole of water on top. Grams cancels grams, leaves us moles, that's what we want. So then you just calculate 62.5 divided by the 18.02, and we get 3.47 moles of water. Next one, how many grams are in 5.34 moles of water? So this is going the other direction. We want to go from moles to grams. So we start with the given amount of moles. We're going to cancel moles and go to grams. So again, the molar mass, grams per mole. And then in this case, we're multiplying across. Next one, we want to know how many grams are in 1.56 moles of calcium chloride. So again, you need to use your nomenclature. Calcium chloride is going to be CaCl2. So we're going to need the molar mass, because when we start with the number of moles, the first thing we need to do is go from moles to grams. So 1 calcium and 2 chlorine, so we add up the pieces, and we get 110.98 for the molar mass. So we're going to multiply across, and we get 173.13 grams, or to 3 sig figs as the original measurement, 173 grams of calcium chloride. And the next one here, we want to know how many moles when we're given the mass of copper 2 phosphate. Again, you have to be able to write the correct formula. We're going to be adding up the pieces to get the molar mass. So we're starting with 456 grams of copper 2 phosphate. We're going to put the molar mass on the bottom to cancel grams, and we get 1.198 moles. It's a little bit trickier when we start looking at going between the number of atoms or compounds or formula units or molecules and grams. So keep in mind that the mole is our central idea here. So we always need to go through the mole. So the first one here, if we want to find the mass in grams and we're given the number of atoms, we can't go directly from number of atoms to grams. We have to go first to number of moles, and then from moles we can go to grams. So what that looks like using dimensional analysis, set up 2.45 times 10 to the 25 atoms of calcium. So we're going to cancel atoms of calcium, and we want to go to moles as their intermediate. So the relationship there, of course, is Avogadro's number of atoms in a mole. That'll cancel atoms, gets us to moles. Then we're going to cancel moles of calcium to get to grams of calcium, and then we use the molar mass. So 2.45, type in E25, make sure you know how to use your calculator correctly the way we've talked, divided by Avogadro's number, times the 40.08, and you should get 1630 rounded off to 3 sig figs as the original measurement, grams of calcium. Next one, to go from grams of gold to atoms of gold. So we're starting with grams. So we're going to go from grams to moles using the molar mass of gold. That gets us to moles. And then moles will cancel to number of atoms, again using Avogadro's number. Next one, how many molecules of hydrochloric acid are contained in 56.7 grams of HCl? So starting with 56.7 grams HCl, so you're going to divide by the molar mass, so you'd have to figure that out. 1 hydrogen, 1 chlorine, gives us the molar mass of 36.46. That will cancel to get us into moles, and then we need to cancel moles to get to number of molecules, again using 6.02 times 10 to the 23. And the next one, 175.37 grams of CuNO3 2, so this would be copper 2 nitrate. And we want to know how many formula units. So starting with grams, well, we're going to have to divide by the molar mass. I will leave that up to you to verify, but you should be able to do that at this point, just adding up 1 copper, 2 nitrogen, and then 6 oxygens. So that will get us into moles, and then from moles, cancel moles to get to formula units, or number of compounds, and then you get your answer. And next one, we're given the formula units, so 8.651 E25. We're going to cancel the formula units. We know there's Avogadro's number of formula units per mole. That gets us to moles. Then we have to cancel moles to grams. And again, using the molar mass that you would have to add up of nickel 3 sulfate, knowing that nickel 3 sulfate is going to be Ni2SO4 3. And if you don't remember how to do that, please reach out so I can walk you through that. But really, you should be able to do that at this point. And the last one.